To our friends at Eosung, try my best here. I young hoss I know. So I'm Jeremy Bland. I'm the Director of Application Development at Polysource. Thank you for allowing us to be a part of this and bring one of our successes that we had with polyketone to really help understand the many different characteristics it brings to applications and the many solutions we have found across many industries. So before we start that, oops, wrong way. Some of you may be wondering, who is Polysource? So a few years ago, we did a marketing campaign where we introduced ourselves as the fixers. By definition, we are a thermoplastic resin distribution company out of Kansas City, Kansas. Beyond that, we are an extension of our customers' engineering teams. We're problem solvers. Our sales team is extremely technical, hands-on with our customers, and focused on application development. So we're a distributor, but we want to go beyond our value. It goes far beyond. We have a great portfolio of materials to choose from, including Eosung. For applications where an off-the-shelf material just isn't quite meeting your needs, we have innovative solutions through our custom compounding network to create our own Integra formulations to meet those demanding needs. So whether you're in design stage, needing help with material selection, or if you're working through an issue with part failures, or even just on the floor looking for troubleshooting assistance, Polysource offers support in all of these areas. We do a lot of development with OEMs in the US, and through our warehouse support network, we're able to supply these materials virtually anywhere in the world. Our approach to application development start with these 4 elements. Obviously, as a material supplier, we're first in material selection, but we also have expertise in mold design, part design, and help with processing. What we find in successful products, when they miss their target, they're not having feedback and support from all of these areas. And those obviously lead to excessive scrap, costly delays, and even part failure. For material selection, we take a similar approach using what we call the Polysource design funnel. I'll be honest with you, we ask our customers a lot of questions. That is intentional. And we want to have a conversation about these 5 aspects of your application to uncover key insights and ensure that we're looking at this from a 360-degree level and not missing anything. So leading to stronger and more effective designs. So today's case study I want to bring up, it's a little bit older one. I think we've been working with Eosung for a little over 12 years now. And this was one of the first applications that we came across. Customers having some serious issues. But over the years, we have continued to find applications in many industries where polyketone was a great solution, and we continue to do so today. Today's case study, we're looking at polyketone in the material handling area, specifically in modular conveyor belts. So those of you not familiar with modular conveyor belts, there on the right-hand side is an example of one. Injection molded part, they fit together similar to like Legos. They are connected with a connecting rod and are able to fit any width, any length conveyor belt that you may have. Just a handful of materials that are used in this market. POM probably being the lion's share of most of these materials. There are some unique applications where a few other polymers go into that. So aside from typical conveyor belt applications where strength and low wear and friction are needed, this particular application was in the protein processing industry. I struggled to find a picture that wouldn't shock you. If you've ever been in one of these plants, it's beef, pork, and poultry come in one side, chicken nuggets and hamburgers and pork chops come out the other side. So this picture gives you a little bit of an example of what they're doing in there. And they're really moving these carcass from one department to the next as they continue to break them down and package them. So aside from the typical needs, toughness, specifically drop impact, and cut resistance are important. So in the case of a beef processing plant, you start off with like 200 kg sections of meat that are frozen. The rooms themselves are at just over 0 degrees Celsius to keep bacteria growth from occurring. And these 200 kilogram sections fall onto the belt, so drop impact can be a concern. Cut resistance, as they section these down, the operators, as you can see in the picture here, they're using knives directly on the belt. And so over time, these belts get marks on them. Great place for a breeding ground for bacteria. It is often why they would replace a belt. Palm was working in this application. As we got involved, we started to learn a little bit more about where other failures were occurring. So drop impact being one of them. Occasionally, when one of these large sections of meat would fall, it would break the belt, causing not only downtime, but also a concern for polymer contamination with the meat product. And then, of course, I mentioned cut resistance is probably the number one reason they would replace belts. Chemical resistance is also important because we're having to sterilize these belts all the time. And then because they're used across the world, compliance with food contact is another consideration. Down in the lower right-hand corner there, you can see a gentleman cleaning a belt. So a typical processing plant like this will run 2 shifts. And in the third shift, the entire belt, everything gets broke down, cleaned, sanitized, scrubbed, put back together for the next day's production. So along the way, the Food Safety Modernization Act of 2011 was starting to be enacted. It was about 2014 once it finally made it to these plants. And peracetic acid was introduced as a new daily sanitizer, replacing hypochlorite formulation. Part of this new regulatory was that your meat products could not touch hypochlorite or come in contact with surfaces that have been with hypochlorite. So that's why peracetic acid was introduced. It didn't take long, and this is about the time that we received the call from our customer, because those palm belts, the peracetic acid did not mix well at all, and belt life was severely reduced. So typical module made of palm would last 2 to 3 months. Again, cut resistance and drop impact that could potentially be cause of replacing it. Now that peracetic acid was being used, some of these modules were breaking in as little as 2 weeks. Increasing manufacturing cost, downtime, and then a new concern with this polymer fragments mixing with the meat because they were breaking so regularly. So this is where we got involved with our customer. They brought the problem to us and said, we need some help. Through the design funnel, we started looking at it and really the chemistry behind the problem that they brought to us with peracetic acid. We can see how it readily breaks down the carbon oxygen bonds in POM, but has no effect on POK. Oops. Continuing through the design funnel, POK has a great regulatory approvals. Didn't have a concern there. Like you said, they meet all the FDA and other countries' food contact. We did some studies to show that POK has superior wear and friction performance. And as you can see on here, we definitely improved the wear resistance and at different rotational speeds that the customer would need. And then mechanically, and Kate mentioned earlier, POK has 3 times the toughness as POM. So really looking to be a good candidate for next steps. And so we did just that. We went to our customer, we sampled with them. Parts came out looking great. Dimensional requirements such as pitch and length are very important as these fit together. And we were able to meet those without needing any mold modifications due to its similar shrink rate. And then, of course, the resistance of the sanitizer appeared to be good to move forward. So the next logical step was to get this belt in production to see how it was going to perform. So as they were mentioning, POM was lasting about 2 weeks. So we started calling about that time frame to see how was it going. Things were great. Weeks turned into months. And finally, at the 9-month mark, the customer couldn't believe how well it was performing and decided to just take it offline and replace it just because they thought for sure this thing was going to break eventually. It did not. We also had some unexpected benefits of polyketone. So we mentioned cleaning happens every day. And with the POM, protein residue would stick to the belt. So that led to a little bit more elbow grease needed to clean these belts. But also, as you can see on the bottom side there, they were losing products. So improvement there because, like I said, it did not stick with the POK. Cut resistance was improved. They never had to replace a module because the cut marks were so severe that they were worried about bacteria. So we reduced that. And then, of course, because we didn't have any breakage with the polyketone, the concern for contamination was completely eliminated. And then on the molding side of things, we were also able to reduce cycle time by 15%. So for the customer, polyketone was truly an amazing problem solver. I think that's it. Yeah. Thank you again for inviting me.
So the morning session has been ended, and lastly, we have 2 questions. So one is that shelf life. What is the shelf life of polyketone? And then we can answer that. Actually, polyketone has been licensed by the Shell Catalan in 2000. And we launched our own polyketone in 2015. And then when we launched our polyketone, then the previous customer who used Shell Catalan asked us, do you have same one? So now, yes, we have it. You can use it. And that means that was 15 years. So Shell Catalan customer, 15 years, they had stocks and used. And after we launched, they asked our polyketone polymer and we used. So indirectly, we can tell you that is minimum of more than 15 years. And second question is that what is polyketone extrusion grade? Could we use mass production and material selection? Just give me a second. I can answer you in the presentation. So now I can tell you, we have some of success story for the extrusion with polyketone. Some of that is from the USA, which is the download the pipeliner, and some of them from the continuous endless corrode, which is the co-extrusion with coated outside of polyketone. Inside is for the just the carbon steel and coated with polyketone. And bottom one is for the stock ship from China. And the middle one is that the fuel tube or the air pressure tube. So polyketone is available extrusion, but we need invest time, resource with our close relationship. Yes, every question has been done, and thank you for today morning session. And one more thing, we have a afternoon session starting 1 p.m., which is our European number one distributor KDF. 2 p.m. And Gunter, who is the hot runner morning, that starts 2 p.m. And again, for the morning session, we truly appreciate our partners, the Acro, Desco, and Polysource. Please give a big hand again. Yeah. Yeah, please. I'm from Saudi Arabia, and we are looking to replace for the K20 state of the state. We can for the oil and gas. We see the temperature is good, and we see the comparison with the electricity with the nail. Can we make it a pipe, standalone pipe? Can we reduce polycatone 4-inch, 6-inch, and we coil, and we make a brusher? What's the maximum brusher we can? That by brusher bar or piece, not as the gentleman that your MRS. What do you earlier talked about the was it MRS study?
Yes, we have tested the MRS with 30% glass filled material, 11.2 megapascal, and M630, 14.2 megapascal.
In Europe, we see we calculate by bar, or in US we calculate by PSI. So you have any calculation with it? I think it's is it 1100 PSI, like 1102 or something like that. Is that right?
I'll calculate.
Any other question you have it? Or no? Thank you very much again for the morning session, and we'll see you soon in 2 p.m. Thank you.
Yes.